Hi, I'm Andrea. Today I'm going to talk about sort of the platform, the analytics platform that we're trying to build out at Mars. There we go, got it. Just a little bit of background on myself. I lead data engineering for supply chain at Mars. I've been with the company just over a year. Prior to that, I was doing consulting on big data and cloud analytics platforms. And so while I say consulting, I didn't work just in an advisory role. I was also doing some of the actual implementation. And I think that's probably why Mars hired me about a year ago. So the lens that I've been coming from is more of the startups and the technology companies of the world. So I wanted to take sort of what I did there and share my experience with how we brought that over to a very large global enterprise like Mars. And a couple things that I wanted to talk about today. One is just how do we deploy technology at this scale, number one. And then number two, how do we land and socialize that with the organization to drive change? From my previous experience with tech companies, it's easy to say, hey, this is cool, new tech, this is the right tech, this is what we want to do, implement it. But at Mars, it's a little bit different, right? We can't just do that. We have to also socialize that with the larger organization. So Mars, hopefully everyone here is probably familiar with Mars Wrigley, as you may know it if you're a Chicagoan. But if you don't, you probably know some of our iconic brands. So Snickers, Twix, Skittles. If you're in the UK, it's Galaxy. We have Uncle Ben's. Also, your pets are probably eating Mars as well. If you didn't know, we own a portfolio of pet food brands. We are across the globe. We are truly enormous, massive scale, right? And so as a part of that, we have end-to-end supply chain management as a large component of what we're doing. So if you think about everything from sourcing those cocoa beans to the finished product that gets on a truck to a customer, we are managing that supply chain end-to-end. So for us, these KPIs and metrics are really what drive our supply chain and drive us to continue to manage it. Make sure that our processes, we're adhering to our business processes and we're meeting those SLAs. But as we all know, that's not enough anymore. We need to do more than just sit back and monitor these KPIs. We actually need to be proactive. That's in order to stay, competitive in the market. And so as a part of that, we want to think through how do these KPIs interact with each other? They don't just exist in a silo. And how can we pull these individual levers to sort of impact the change we want to affect, right? And through all of that, we're going to get to better decision making. And so as a part of that, Mars has embarked on this digital transformation journey. Mars is investing very heavily in analytics and data science, and that's why we're all here today, right? But I'm going to give you the punchline early, which is I'm not here to talk about those today. And I don't mean because they're not interesting or because they are not important, just more when it comes to, analytics and data science, the foundation is data, right? We can't do those things without data. And that's, in particular, high-quality data that's highly available and exploitable. So how do we get to that point, right? For Mars was really, we want to be intentional about our data strategy so that we can really do those things and do those things well. So if data is so critical, how do we build the right platform and solutions to serve that end? And then, my personal take on all of this is how do we do this at enterprise scale with open source technologies, which are near and dear to my heart, which we'll talk about in a little bit. So just to give you a little bit of background on where Mars is analytically, or analytics capability-wise, I should say. We've recently moved to the cloud. So our legacy systems, they were largely sort of coupled with our transactional systems, and they've persisted for years and years and years, and so over that time, we've started to develop these data silos, right? So they're almost like black boxes for logic. You want logic, they go into the silo, and never again can you untangle this thing. The other thing that we have is when individuals leave, we lose IP, right? Because we didn't necessarily always document this stuff perfectly and keep it in a way that's reusable. The other bit is that with these legacy systems, there's really little interoperability with other tech that we want to sort of serve this new vision for data and analytics. So Mars moved to the cloud. I'm a huge fan of the cloud. Obviously, I did consulting on that previously. But there's some really neat aspects of it. I know there's a ton of great things about it, but I'm going to highlight a couple that are important for us. So if you think about like what we can do today, with the click of a button, you can provision resources. You can get a computer in the cloud. This is super powerful. I mean, think about previously, you had a server, you had to order that server, and then you had to wait for it to, arrive and then install it in your server room, right? And then you're always at your, you can't scale back in anymore. So this is really a powerful concept. We can click a button, spin up a resource, click a button, tear it down, right? So we can get massive scale while also being cost effective. The other sort of bit of this is the data lake piece, right? So now with our cloud platform, we have this great data lake where we're ingesting all of our data into one place, one centralized repository, right? This is great. All of our internal systems, we can dump that data into this one persisted file store. And so this is sort of key to the next point that I want to highlight, which is that, the principle of sort of decoupled storage and compute. This is something, unfortunately, a lot of people at Mars have now heard, ad nauseum, but it's really important because what we've done is we've said, okay, we can dump our files to persisted storage such that we only need compute when we need it, right? So if I want to process that data, if I want to analyze it, great, I can spool up my compute and then tear it down. So compute, as we all know, probably is the most expensive part of that equation. So this helps us get massive, massive scale while being cost effective. The other bit is we are leveraging distributed processing frameworks. So in the cloud, we run clusters. Remember, I'm data engineering, not data science. So we're leveraging clusters, on top of which we're running Spark and then Databricks for our cluster management. A little other, I guess, bit of context that I want to give to what we're doing is how we've been structured. So we have this opportunity for massive, massive scale, right? We're in the cloud, but we also want to increase our velocity horizontally. So what we've done is structured analytics into sort of these project pods, right? And we're adding third-party resources. So we have pods of third-party developers, sometimes we have internal developers, and then we have business who are all sort of together and responsible for delivering those products end-to-end. And this also has implications for the development space, right? So our projects are actually physically separate in the cloud. So great, right? Analytics cruising along at Mars. So what we start to hear is actually the business saying, where's my dashboard? When is it going to be ready? Why is it taking so long? And we have our data scientist up in the right corner. I think not going to happen. Fine. We have our data scientist up in the right-hand corner who's like, hey, I need these features for this model. Where do I get those? I'm looking in the data lake. Where are these things? This is pretty confusing. We have our business data analyst who's like, hey, I just want to poke around the data. I want to generate some insights. I want to create some reports. How do I do that with the data lake? It's not particularly straightforward. And then we have our data engineers who are like, hey, okay, so where is this data in the data lake? How do I ingest it? How do I process it? And how do I structure it and model this data with other data sets? So what is sort of becoming apparent is that there's some pain points, right? We have some pain points. And I think one of the ones that should potentially strike a chord with many people here is it's difficult to exploit data lakes, right? We know that routinely, data lake efforts do fail at organizations. And I think part of the reason is files are hard to work with, right? They're not our standard analytics currency. If you think about it, you have to look for a file. Where is that file? And if that file is coming in at some regular cadence, how do I merge this thing? How do I have this unified, cohesive data set to work with? At a company like Mars, the other thing is data modeling. This is really, really challenging. If you think about our supply chain again, from that raw material, that cocoa, to a finished product, all of that can happen through our transactional system. And how do we actually model that flow? Especially when we have multiple transactional systems, we have multiple deployments of said transactional systems, and we have multiple versions of those. And sometimes across business units, those systems differ, right? And again, we have individuals leaving, IP leaving. There's also a component of business process. So again, Mars is huge. We have tons of business units. Each business unit can have a different business process, and that obviously has an impact on our data. The other bit, and this comes more from the fact that we've structured things as projects, is we have now inconsistent patterns for data access and consumption. So I'm over here doing my thing, and then you're over there doing yours. How do I get access to this data? It's not particularly salient, right? And then this has an implication for our architecture and our IP. While you can share with me what you've done over here, I can't access it because I'm in my own little space, right? So this leads to inability to really scale our products very easily, and then no sort of cross-sectional view of everything that we have data-wise or demand-wise. So how do we solve these pain points, right? So when I came to Mars, that was sort of the first thing that I was thinking about is how do we solve this, how do we fix this? Because we want velocity. If you hear our CDO talking about this, he says 100x. So how do we get to 100x, right? That's my goal. Well, so there's two things, and this is something that I brought up in the beginning, which is, number one, there's a technical solution, right? Or at least I believe there's the right technical solution. And then number two, there's also sort of the strategy around that, right? Because we have to socialize and bring in the tech to the wider organization. I can't just go there and implement it. So our solution to number one was a centralized data warehouse built in the cloud, leveraging open source technology. So this is really critical, right? Now all of a sudden we have one access point for data, not all over the place, not the data lake. We can now abstract up from that data lake with one access point, right? So projects, they don't necessarily have to always touch that bit of it, the hard bit. We also have a place to house our business logic and to preserve it, right? So this is really, really powerful. We also then have the cross-functional view of all the data and the sort of relationships between those data sets such that we can start to have that horizontal data model that we want anyway. So I will talk specifically about what we did. We leveraged Apache Hive. It is an open source tool. I love it, but I also really love open source, right? I mentioned that. And there's a couple reasons. One is that it's completely transparent. We know the code, we can access the code, we can change the code. Number two, there's really amazing development communities around these open source technologies, right, across the world, actively developing on it. And if you think about it, like, you're going to get innovation probably faster than some of these enterprise products. The other bit is, you could have someone in business, someone in research, all these different use cases they're building to actively. And it's also cost effective, right? So it's free. We don't have to buy licenses for these things. So very, very powerful. So talking a little bit more about Hive, all Hive really is just a metadata layer on top of files in the data lake. So really what it does is it provides this abstraction such that these files look, smell, taste like tables, and you can access them via SQL. So this is a lot more of the standard analytics currency that people are used to. So what is Hive? Hive is, well, it's sort of an ecosystem. So you have your metastore, and all that is a SQL database that houses metadata on the files. It does not store any data itself, right? This is key. And then it's also sort of, on the other hand, an engine that allows you to process data from that metastore. Our implementation is also sort of very critical to this. So we leverage an external metastore, and I'll try to explain that. So Hive has previously, or in certain cases, is deployed with HDFS, Hadoop Distributed File Storage. And what that means is you have your data, it's sitting on a cluster, and you have your metastore also sitting on that cluster. So when you turn off that cluster, you lose not only your data, but you lose the metadata about it. So with this external metastore, we've actually kept all the data in the data lake where we want it, right? We want to leave it there. And then we have this external SQL database where we house all our metadata. So it doesn't matter whether we turn on compute, turn it off, it persists. This is also hugely powerful, right? Because now I can say to my engineers, hey, provision this cluster, and you'll leverage Spark, fine, connect it to the metastore. Another group comes and they say, hey, I want to do that too. They can spin up their own cluster and hit it, And then if I have, an analyst who's like, hey, I want to do some querying, I can spin up their own cluster. So all of these things I can stack up against this external metastore. So hugely powerful for scale. The other bit is, so we leverage external tables. Again, this just means our files are stored in the data lake. We leverage a particular sort of file format, ORC. It's a columnar store compressed file format. It's optimized for sort of data warehousing analytic type queries, so it's more performant. It also encodes type, so that's really useful, right? That's good for our data warehouse. And so the motivation for Hive, and in particular, was it really provides this centralized access point for data, but at scale. So if you think about legacy data warehouses, yes, it is one central access point, but you don't necessarily have the same scale that you do with Hive. It's also, again, a framework to handle large data sets. So maybe individually Mars doesn't have, like one application that has huge data, string them all together, and there's a lot to process, there's a lot to handle. It also supports partitioning. We can sort of partition our data in a way that's optimized for updates and query patterns. So this helps performance. It's cost efficient, as I mentioned, and you get a SQL interface and a JDBC ODBC connector. Two other things which are sort of more particular to our use case. It allows us to store interim data sets for ongoing analysis. And then also we have sort of a real-time metadata sharing across environments happening. So this is sort of an event-driven framework that we put together. I won't go into detail on it, but I'll just quickly summarize. So if you have dev and prod, and you have your data refreshing in prod, at some sort of cadence, you're updating the metastore. You can share that metadata with your dev environment, so you continue to keep that isolation, and you're not copying your data over. You're simply sharing the metadata, so dev is simply reading prod. So this is just high-level reference architecture. As you see on the left-hand side, we have sort of our data storage, so where all our files are living. On top of that, we have our metadata layer, right? So if you have your compute engines, if you're running Spark, Hive, Presto, what have you, you always want to hit those files through that metadata layer. And that allows you to actually view them as sort of cohesive data sets. Again, so we have our data engineer who's running that Databricks cluster with Spark running on it, hits the files, can leverage all the data in that data warehouse. We have our business or data analyst who maybe is proficient at SQL, can write SQL against it. Otherwise, they can sort of manipulate things with Tableau and Power BI, which is standard tooling for Mars. We also have our data scientist down in the corner who's on their notebook environment, and they get to explore these features in the data warehouse. There's business also by the data catalog, but I'll get to that in a bit. So the second piece of this puzzle is we have sort of the technical foundations for how we want to solve these problems. There's also a strategy that, that's involved, right? And in particular, this strategy is important not only to support new development, but also critically self-service. So how do we sort of unify these architectures such that, we can serve things with repeatable patterns? And that allows us not only to define how we sort of interact with projects, but it also allows us to have that sort of layer of abstraction, where we can start to create libraries and UDFs and all these things that get to be reused, right? And this is where we're going to get scale and velocity. So our data strategy. It may seem trivial, but just the first thing was creating a common language around these things. The business probably has a bad connotation with files in the data lake because it's been really hard for them to leverage them, right? So we don't want to talk about files anymore. We want to talk about data assets. And that's not like a novel term, but it was useful in encoding that, hey, it's not a file. We've done something to this data set to make it a more cohesive data set. There's something, we've encoded some sort of special meaning to this thing. So we started using the term data assets. The other was persisting a team that we've termed the data engine. That's also another work stream that I lead in conjunction with projects. And the data engine, it speaks for itself, right? It's literally just creating data. And what's nice about this team is that we get the horizontal that we want, right? We get that cross-sectional view of the data. And this allows us to create those reusable patterns through which we interact with projects, or really through which projects interact with us. We also set up a data forum with users. Again, really sort of, in my mind, simple, straightforward, but really effective. So every week we sat with users for like 30 minutes, answered whatever questions they had, even if it was simply like, hey, I don't know how to do this thing in Tableau. If I could answer it, I would, right? And we also, if they had requests for, hey, I want to see this in a report, if we could service it, we did. And so on the one hand, we engendered trust with the business, which we didn't always have, because the data lake didn't always perform or give them what they had, intended. So we also then were able to upskill our users while also getting something out of them. So we got the business logic behind some of these business processes that were otherwise opaque, right? And then we got that validation, because obviously business process has a ramification for what the logic looks like behind that data. The other bit is enabling self-service. We all have our thoughts probably on self-service, but I think where we are now is we just couldn't continue to be the bottleneck. We have to give people a way to access their own data. And so that was something that was really, really key for us to sort of instrument these patterns around. The two bits that we're still currently working on, that are actively evolving as a data governance body, we've created this data warehouse. We don't want to put crap in it now, right? We want to keep it somewhat clean. And so trying to determine how we work with projects to do that is what this body does, right? We want to make sure that when we're putting data assets or data models out there, they sort of conform to certain standards and they're reusable. We don't want it to be the case that we put this thing out there and it's bespoke to this particular narrow scope of a project. The other bit is how do we get the business around this? And I think the problem is the business doesn't care about files, right? They never did. They also don't care really about data assets all the time. There's one layer of abstraction that is really important, one layer up that's really important to them, right? And that's KPIs, because that's how they run their operations. So giving them something such that they could, look into, hey, I want this KPI, that KPI, this KPI, really powerful. Also, from our end, we get to see, is this a global KPI? Is this something that other business units are using, or is this bespoke, right? So we can give them insights they previously did not have. So data organization, probably something that everyone here may think is trivial. It's actually super non-trivial for us executing on this strategy, which is why I'm highlighting on this slide. Number one, naming conventions really important. They never change. So that's something we learned. It's really hard to change them once they're out there. And then number two, just how do we organize our data warehouse? So one of the principles was getting these 3 layers in. So I'll just describe those briefly, which is we have 3 layers in our data assets, and they also are reflected in physical paths in the data lake, but to users, it's really surfaced as like naming conventions and schemas. But our base assets, what we wanted with these is really to just reflect what is in the source. So if we're pulling in a source, let's say that source has an application backend, a database with tables, we're just reflecting those in our data warehouse, simply reflecting those. We also have a layer that we term the composite asset layer, which is some of this more like model data, the data where we've actually encoded the relationships. But this is really key because in this layer, we can, let's say we develop something for one business unit, we can easily apply it to another. So the next layer is reporting assets, and the only difference between these and composite is now they have business process. Right, so that's the only thing that's different is now that we've encoded in our logic business process. So if I want to scale this to another business unit, I can't necessarily do that, right? Because my business process may be different. So I have to check, hey, Pet US, are you doing the same thing that Confectionery US is doing? If so, great, we can scale it. Otherwise, we have to do some work to get that same data out there. So why this is important is again, how we interact with projects, which we can't get away from that structure. Projects are how we get funding, it's how we get velocity across our various regions and segments, which are huge. And what this allows us to do is leverage that data engine, that horizontal work stream producing data, to maintain that base and composite layers. So, we get to structure how, our ingestion pipelines are running these best practices, and the projects only interact with that reporting layer, really. So they're sort of siloed in what they're doing. So just to quickly go through some of the results, I can't share exact things, but we do see cost savings. So previously, with infrastructure, we had farms of SQL servers in the cloud running because they had to persist the data for all our various data products. With this new strategy, we could be a lot more intentional with our compute, right, which is expensive. So we could determine when we wanted this on and how we wanted it and how we wanted to scale it. So we've seen some cost savings on the infrastructure side. We also see a huge cost savings with our third-party resources, right? Because now all of a sudden, they're starting further downstream in a project. Instead of having to start from the beginning with all these ingestion pipelines and figuring out how to model all these like source systems and such, they get that. They get that through the base assets, the composite assets. And now they're really, and so they're starting at a much further place. So we don't have to have as long and large number of people on these projects. The other bit is we've just put in place sort of a flexible architecture that allows us to support future patterns. Hive is not a silver bullet. I've never said that. It's just the foundation, right? But it's going to support a lot of other things we want to do. It also has enabled us to bring back, to rebuild our IP. This is really critical because if we want velocity, we have to bring that back. Otherwise, we're never going to get there. Additionally, we simply have reusable, scalable data products. So these are the things that we want to now start driving those advanced analytics, the data science, the AI, the machine learning. And we have, at this point, we have the organizational buy-in to continue doing this work to build out this platform. So that was really key. So just to quickly summarize with Mars, it's been an interesting journey for the last year, but I think we've had great success with this, and we had great success because again, at an enterprise as large as Mars, it's not just about the tech, it's also about the strategy around that and socializing that with the greater organization. So I think I'm 2 minutes early. That's it. Thank you all.
Thanks for the talk. So I just want to get your thoughts. I work for a packaging company. We are part of your supply chain. So most of what you have presented today is inward looking. So you're working internally in your organization. So just want to get your thought. What will be the next step in this journey? Are you thinking about looking outwards, partnering with your supply chain, implementing any of these policies, and how you see that coming, if that will be necessary to get to the next level?
That's actually a great, did I do something?
No, you didn't do anything.
Okay, great. No, that's an interesting question. Right now, we're very sort of internal focused because even internally, just trying to map our own supply chain with data is extremely complex. And we don't necessarily always have that full transparency end to end. So I think the hope is that that's in the roadmap because we need to start doing that to be fully transparent. And I would anticipate, hopefully within a year or two, that's where we start to get.
That makes sense. Thanks.
That's not the best. I know, I get it.
I understand.
We're building the foundations, right? That was the...
So we have a question, how do you handle data quality? Meaning that how do you ensure that the data is not corrupted or accurate and so on?
So through this data engine that we built out, what we've tried to do is really standardize and get to a place where our data pipelines are, well, I should say, we're the ones who are sort of owning that internally. So that's not external, and that's not happening in a million different places. It's happening out of one place. And for us, we have a lot of validation checks that run as a part of those. So something that's really important for us is making sure all these things are sort of decoupled in such a way that we know when things fail in our pipeline and where they're failing. So for us, we leverage SAP, and SAP, this huge amounts of complex sort of transactional data. We have certain checks in place that'll trigger alerts should things not be met. But we're actively monitoring our pipelines and supporting those pipelines daily.
Hi, thanks. You mentioned all the data assets and consolidating and having all the different layers. Are you finding a lot of efficiencies across Mars defining the data, or did you have to build quite a dictionary to understand everything across?
Yeah, so that was the okay, I'm back on. That was the interesting bit was what happened is we started with these projects, right? And we're like, oh, all of this is starting to overlap. Why are we working in this manner? And so that's when we started to take that cross-sectional view. And that's when we, discovered that you do something for one business unit. If you're in that composite layer, you can do it for the others, right? It's simply just how is that data related? That's it. And then it's that reporting layer where you get the business process involved, and that's where it gets a little bit more nuanced, right? Pet US may do something very particular with their inventory that confectionery doesn't. And so that's when you start to have the variances, and when you want projects to actually start digging, right? That's when you want people to start digging. But everything else should be, for the most part, somewhat reusable, so long as source systems are similar across, across whatever data you're looking at.